Hello everybody, this video is about the explainable artificial intelligence live with random forest regression in Jupyter notebook. So let's go to notebook and start working. So the first thing we need to do as usual is to import the dataset. For this purpose, we need to import the library pandas. So import pandas as PD, then we read the data. Let's call it my data equal pandas.read underscore comma separated value. And the data set is found in E. This is the directory. Set tech docs data. Data set is called lake. Comma separated value. Okay, let me verify. Yeah. Data with capital D. Okay, alright, let's run. It's loading here. Okay, good. Yes. Okay, let's set the seeds to 7 to make reproducible the code. Reproducible. Good. Let's have data exploration, a brief exploration. Let's have an idea about the shape of the data. So my data dot shape. Let's see the dimensions. Has 240 observations and 8 variables. Let's have an idea about what is in the data. My data dot head this is what we have in my data lake. Yes, let me start with the last one. This is LL it stands for lake level. This is our target variable, and ET is T stands for time. We are going to drop it, and these 6 are our feature or input variables. So you have evapotranspiration here, specific humidity, 80 stands for air temperature, ST is soil temperature, P is precipitation, SM is soil moisture. So if you want to have an idea about the description, my data.describe. it's brief descriptive statistics. Okay, we're good now. So let's have our input and output data preparation. So let's start with output and input data preparation. Start with the output data or target variable. And y, as I said, is my data is lake level. So from my data we take lake level. Let's check its dimensions. So a column 240 observation. This is what you have. The input variables or features. X for my data. From my data we are going to drop lake level and the t, which is time. So parentheses, bracket, quotes, LL, then also t. And the axis equal to 1. So that's all x. Let's have an idea about the dimension of x. X dot shape. We have our 6 variables and 240 observations. And 240 rows and 6 columns. X dot head. This is what you have, the 6 columns here, corresponding to the 6 features. So as I always mention, you need it before going to splitting the data set. You need to run the variance inflation factor and scale your data. Variance inflation factor VIF, the scale, the features, excuse me. Before continuing to the next step. Okay, we'll get to the next step. Splitting the data set into training and testing data set. For this purpose, you need to import function, train, test, split function. From scikit-learn dot model underscore selection import train test split then after that we need to proceed to the split of the data set itself. We have x train, x test, y train, y test equal to train test split have x, y, test size equal to 25%, random state take 30, shuffle equal to 2. Okay, now let me check the syntax. X underscore test. Good. To check dimensions. Type print x train dot shape x test dot shape y train dot shape y test dot shape. So these are the dimensions of the respective X features and observation for the training and testing data set. Features and targets, sorry, for the training and testing data set. So now we read to random forest regression. We need to import the necessary libraries and functions. So from scikit-learn.ensemble we need a random forest regression. Then we need our matrix. So we have scikit-learn dot matrix to import R score. We have our R square, the mean absolute draw the mean squared draw in addition to that we need the cross val score from scikit-learn dot model selection. Val score. We also need NumPy as NP, and from NumPy we need absolute to transform negative values into positive. We may have some warning messages, so we need to suppress them. To ignore or suppress. Warning messages. We need warnings function and from warnings we need warnings dot filter warnings ignore. Good. So next step to instantiate the model. So our model, to random forest regressor. Number of estimators equal to 50. Max depth equal to 12. Mean samples leaf equal 4. Mean samples split equal to 2. And then max leaf node, max leaf nodes equal to 5. So to have this parameters, you need to run your own hyperparameter tuning to build this for your research. Whatever data you are using, you run your hyperparameter search to get these parameters. Okay, so this is the model. Number of estimators, max depth, mean sample sleeve, mean sample split, max leaf nodes. That's what you need to run. Then to fit this model, using the training dataset. So to get the random force, so rf equal model dot fit s train y train. Good. So now we need to evaluate the performance of the training model. For this purpose, we need our training model first. On the training, yes, the training model. So call it random forest, the prediction on the training model. So it's rf that predicts. You predict on X train. Good. So now we print the R square. On the training model. The training R square is R2 underscore score y train and its corresponding predicted value, which is rf underscore predictr. About 52%. Say 52. And we print the training, then absolute error is mean absolute error of y train random forest predictr. About 0.25. The training MSC is mean square your y train predictr. Point 10. Testing model performance evaluation. So this time we need to predict on the testing rf but yes, rf.predict on x testing data set. And then we print the r square and say the testing square is r2 underscore score test ypad rf at yes. That's about half of the training. That's not a good model here. In terms of r squared, so this testing MAE is mean absolute eval y test rf add yes. MAE is higher on the testing. Let's see the MSC. Oh, sorry. The testing MSC mean score error is okay. The metrics on test data are lower. Okay, let's see the k-fold cross validation. And the training data set. Cross validation for training model, cross underscore score from x train y train. We have RF before that, number our model. The scoring, I take negative mean score, so mean score error and number of folds 1 to 10. That's how this way to get 10 folds. For negative, we need the mean of these 10 folds and the absolute mean. So the absolute mean score enter. Is absolute np.min and the cv tr in the parentheses 2 times. So this is what you get, 130. On the testing data set, cv ts now cross underscore var underscore score rf the model x test y test scoring equal negative mean squared 0 and the number of folds 10. Okay, what is type negative mean squared underscore here. I think this is the only mistake, so cvts. Okay, and we'll print the absolute mean testing cv score is absolute, the absolute of the mean. So numpy dot mean of cv underscore ts. Point 12. Okay. Now we reach our line. That's the purpose of this video. The second purpose, the first is the random forest, second is the line. Which stands for local interpretable model agnostic explanations. For this, you need to go to the terminal or Anaconda prompt or CMD. Yeah, that I usually go through Anaconda. You need to install line there by typing Anaconda prompt or terminal. You type the Anaconda, install Anaconda dash force columns line or type pip install line. Maybe prompt for terminal. So once you do that, you need to come to Jupyter and import the line tabular explainer. So from line dot line underscore tabular from space here dot line underscore tabular import line tabular explainer. And you run. Once you do that, you need to create an object explainer, an explainer object on the training data set. That's the first thing we need to do. Tap it here. So the explainer equal to line tabular explainer from x underscore train dot values you have the feature names is equal to x train dot columns. So in the columns of x train we have the name of the features there, and we have the class name, and that's our y, the target variable, which is leg level, in quotes and brackets, and verbose equal to true. We have the mode. We are in regression mode, so mode equal regression. And regression in quotes, and we close the parentheses. And we run. So once the explainer is already created, we go ahead and make explanations of instances or individual predictions, as well as explanation about the average prediction on the whole data set. So let's start with explanation. instances or individual predictions. Individual predictions. Let's start with the training dataset. So on the training dataset, okay. Let's have our I. This is the index of the, let's say 120. This is the index of instance to be explained. And now we are going to have the explanation on this index. So ex explanation equal explainer dot explain underscore instance we have explain dot values. The values will take only the I. This only need for I, so random forest dot predict. We predict just for I. Then the number of features. So num features we have 6. I run this already. And then there is a typo here. Explain. So for the instance 120, this is what you have as intercept, have the prediction, local prediction, and the right prediction. So if you want to check the instance, you print it. Print parenthesis put the instance is I. So 120 is exactly the same. If you want to check the prediction, we print it. The prediction is the prediction on the training data set for the random forest model. So c'est RFRED tier for our instance I. Our instance 120 is prediction on the training data set. And you see here, it's not local prediction, it's the right prediction. So let's say put right prediction. It's right here, the right. And then you compare with this. Just to check. If you change, let's say 100, you run the explanation, this is what you get. 180, the right prediction, 86.86. 120, it was 281.40. And you print the I 100, and you print the right prediction to compare, and you have 280, 86 here, and so on. So you have to do, let's say again, 80. To 81.40, print for 80, the right prediction, validate, and you see here 281.40, and so on. So you have to go through all of them. So that's for each of the instances. That's why it's better to have just a code to have the average prediction for all the 100. You have 240, so 180. In our training data set, we have 180. In testing, we have 60. So you cannot go through all of them. So you need to write a code to loop through all the 180 to have the average prediction. So this is the purpose of this step now. So explanation of the average prediction for the whole data set. Let's say that way, whole training. Okay, but before that, let's also have an idea about the plots. To show the plot, the table, to show the explainable table, so let's have exp dot show underscore in notebook and code show table equal show underscore table equal to true. Okay, so this is the table explainable table for our index 80. So look at it here. Have the features, the values, is the table. Have the negative impact, the positive impact here. You have the prediction, right? So 281.467 lost is takes 2 decimals, so 41. If you change by 100 back here, you have this. No, this is 10 set. Oh yes, let's let it to 10. So 10. For 10, you have this. Right prediction is 280, 97, 9, so 98, let's say. So the instance is 10. The right prediction is 280, 97, 9. Okay, so it's corresponding the same thing here. Validate. Now we will have the table for it. So this is the table for the instance 10. So for each of the i's you will change here. You have different values for the right prediction, and you have a table like this. So now let's go. There are many things you can get out of this. Okay, let's go to the average prediction for the whole training data set. Here have the train, create an index, a list of the index of what we have in the training as data. So x train dot index dot to list. Sorry, there is typo here. Should be dot instead. Okay. So list of index is x train dot nx. Yes. X train again here. X train dot nx dot to list. And we create a dictionary, put them, and now it is empty. Now we look for n in the list of the indices in the training data set. For n in train underscore nx underscore list. No, it's 4. Good. We have the explanation. Explainer. Same explainer we had before. Explainer dot explain underscore instance. This time we'll have train dot log all the data set we have in it dot values. So we take the prediction, kind of for us predict the model, number of features is 5 equals 6. Number of samples in our test training data set, we have 180. Right here, 180. Now you can just print here, type xtrain dot shape. It gives you here 180 samples, and you have 6 non-feature 6, and non-samples 180. Okay, good. And close the parentheses. Now you have an object A where you put the list of the explanations. So explanation as list. Then you put it in the dictionary, train dict. A. So let me delete this. this SML index out of range. Should be 179. Let's see. Fine, and let's let me check the code. Should be on it, so let's go. And let's list extrain, pattern x2 lists. Okay, dictionary empty for n in train, explainer, data explain instance, explain, lock dot values, of that predict, no features equals 6, no samples equal normally 180, then explanation, release, equal to 8. Let's see here. Okay. Let's have now as list equal to explanation dot as underscore list. Okay. Now we put in the dictionary. So train underscore dict quote n equal to a. Okay, so I see it's not a bracket, is a curly bracket here. Dictionary is curly bracket. Good. So sorry for the typo here. This was the colon, the dictionary, and here isn't curly bracket. So the cause was okay. But this mistake here. Instead of brackets, curly bracket. So this is what you get for the 180 samples. This is the average prediction for all of them. So you have this, and on this 180, tab explanation, and we show the explainable table. show in notebook show underscore table equal to 2. So this is the average. This is for the average prediction. This for individual predictions. This table for the individual predictions you put here. The eyes, each of the eyes has its own table. And below here is for the average of this average prediction. So this table is for the average prediction. Okay, so if you want to continue to output information, for instance, the importances, the feature importance, to retrieve the feature importance as a list. The function as list should be used here, so type explanation dot as underscore list. This function gives us the list of the average importance for the 6 features here. And if you want this to be output as a map, as a dictionary, you get it as a map. You use the function explanation dot as map. Simple like this. This for the average. You can do the one for the same thing here as a list for the individual predictions here as well. If you want to save this plot in the table, type exp.save save to file. And I give it a name. Call it line unknown forest and training dataset .html. As an HTML. Okay. We do the same thing on the testing data set. First, explanation of instances, your individual predictions. Here let's say I equal 20 or 15. The index of the instance to be explained, and we have the explanation equal explainer dot explain underscore instance. This time we'll have x text dot values take I for I in brackets. You need the explanation of it. We have the random forest predict. On the prediction, the number of features 6. Good. Sorry. Name features equal 6. Again, if you want to check, you print your I. The instance is I. To verify it, the index 10, and then you find the prediction is to verify the prediction, the right prediction. You have unknown forest underscore pred ts prediction for I. When you compare with this, right, here to verify. Good. And here to show the explain table xp dot show in notebook show table show underscore table equal to true. So this is what you get for the index 10. Index equal 15. Did I run this? Sorry. Index 15. Okay. Okay, I didn't run this. That it was the 10 for the previous. It was on the training. So I can. You always need always to run. So yeah. When we run this, we run this. Yep. So this is for the testing data about the index 15. If you change to 10, this is what we get. This is what you get. Run again the right prediction, and now we run the table to see the table for the index 10. You can compare this for the index 10. You have the prediction, the right prediction here, 8, 1, 11, round it, max here. You have the negative contribution, the positive contribution with the features here, and the feature value tables, and so on. We have max is 60, let's say 50. You run, that's prediction for 50, the index 50, we run, we verify the right prediction, it's the same. Now we run this to have the table. This is the table for the instance 50. So now let's see the average. Explaining prediction for the whole testing data set. Okay, we do the same, have a list of the indexes of the data in the testing data set. So equal to x underscore test, x test dot index dot to list. And then we have a dictionary as well. Equal, this time let me put the curly bracket instead of brackets. So curly brackets. Before I put brackets and it was out of the range. Now for n in the test index list, we have the explanation, which is equal to explainer dot explain underscore instance parenthesis have s text dot log dot values log n dot values random forest dot predict, make the prediction, non-features equals to 6, num number of samples num samples equal to 60. If you want to check, you just type xtext dot shape. Let's give the dimensions. You have 60 here, num samples, that's the number of observations or samples, and the 6 is number of columns or variables or features. Okay. Sorry. Okay. Now, object A, you have explanation as list. It's going to output the explanation as list. Have here. Then you take it, you put it in the dictionary. Dict all of them. Call A. Okay, so we have our 60. Predictions here for all of them. So we need the average, the X be here of average. We need a plot. You see the plot here for the average prediction, showing the explanation tables for the whole testing data set. Explanation showed in notebook, show table, equal to true. There's a typo here, notebook WB. Okay, this for the average prediction, the EXP here. EXP dot as underscore list. Feature importance, add more cells. Explanation dot as map to see the feature of concerns. As a dictionary. To save your data. XP dot save to file, and give it a name, line random forest underscore test dot html quote. Good, and then you run it to save it, and you are good with it. So this is the end of the video. I hope it's going to help some people people who are doing some research to do their analysis. So thank you very much for watching. See you next time for another video.